Good morning, all. Myself, Dr. MD Imran Khan, Associate Professor, Department of Civil Engineering. My topic is manometers. So, first of all, what do you mean by manometers? So, a manometer is an instrument used to measure the pressure of fluids like liquids or gases. It works by comparing the pressure with the height difference of a liquid column. So, manometers operate on the principle of hydrostatic pressure. So, here, manometer can measure gauge pressure, vacuum pressure, or pressure difference between 2 points. So, on which principle manometer works? So, the manometer works on the principle that the pressure at any point in an static fluid is given by P equal to rho into G into H. So here rho is nothing but the density of the liquid and G is nothing but acceleration due to gravity. That value is 9.81. So H is equal to height difference of liquid column. So what are the different types of manometer? So here simple manometer, differential manometer, special manometer. So first of all we have to discuss about simple manometer. So in this simple manometer, piezometer, so it is the simplest form of manometer used for measuring gauge pressure. Then U-tube manometer, a U-shaped glass tube filled with liquid, usually mercury or water. Single column manometer, one side is narrow tube and the other side is large reservoir. So then differential manometer, in this differential manometer, U-tube differential manometer, so measure pressure difference between two pipeline or chambers. Inverted U-tube manometer means what? Used for measuring small pressure difference using a lighted liquid, for example, oil, air. Inclined manometer, tube is inclined at an angle to measure very small pressure changes with high accuracy. So now special manometer. So in this micromanometer, high precision instrument for very low pressure. Well type manometer has a large well on one side and a narrow tube on the other. Digital manometer. So nowadays digital manometer means what? Uses sensor instead of liquid. Easy to read and portable. So now what are the different application of manometer? So first we have to discuss about measuring gas pressure. So used to measure the pressure of gases in cylinder, tanks, compressor and pipelines. The second one is measuring pressure difference. So differential manometer measure pressure drop across walls, orifice, venturimeters, filters. Now third one is HVAC system. That is means here heating, ventilation and air conditioning used to measure air pressure in ducts helps in balancing air flow. Now it is also used in laboratory experiments like used in physics and fluid mechanics labs to measure pressure accurately. Common in Bernoulli experiment, pitted tube reading and pipe flow test. Then calibration of instrument. So manometers provide highly accurate reference pressure used to calibrate what? Pressure gauge, transducers, digital sensors. It is also used for medical application like used in devices like blood pressure manometers. Monitoring pressure in boilers help monitoring steam pressure in boilers and industrial heating system. So ventilation and clean room monitoring measures low pressure difference in clean rooms, hospitals, ICUs and labs. Refrigeration and AC systems measures refrigerant pressure during maintenance. Gas flow measurements helps measures velocity of gases using pitted static tubes connected to manometers. Now, what are the advantages of manometer? So first one is high accuracy. It gives what? High accuracy. Manometer gives very accurate and reliable pressure measurements. Inexpensive means what? Very low cost compared to electronic pressure sensors. No calibration is required. Why no calibration is required? Because liquid column naturally balance pressure, so no frequency calibration is used. Now easy to read here, height difference of liquid column shows pressure directly. Suitable for differential pressure. So differential manometers measure pressure difference very accurately. Now limitation, what about the limitation of manometer? So here first one is cannot measure very high pressure. Manometers use liquid columns, so extremely high pressure would require very tall tubes. Then second one limitation is bulky and not portable. Glass tube and large size make them difficult to carry. Slow response to pressure changes. Liquid movement takes time. Then fourth one is reading errors possible. Meniscus reading may cause parallax errors. Sensitive to temperature changes. Liquid density changes with the temperature affecting readings. Now these are the examples of manometers. I will solve one by one. So first example is water is flowing through two different pipes to which an inverted differential manometer having an oil of specific gravity 0.8 is connected. And the pressure head in the pipe A is 2 meter of water. Find the pressure in the pipe of B for the manometer readings as shown in figure. So the readings are shown in figure. Here there are two tubes which carry water as well as oil of a specific gravity 0.8. So the solution is what here? So pressure at A. So pressure at A is given by PA divided by rho g equal to 2 meter. That is already given in the above question. So here, if you want to find out the pressure at A, so this is nothing but the pressure at A equal to rho into G into, so it become 19620 Newton per meter square. Therefore, the figure 2.22 shows the arrangement. Here, what you can do, taking xx. So this one is taking xs as a datum line. So pressure below this. Here you have to find out the pressure below this. So pressure below xx in the left limb. So first of all, we have to find out the pressure at the left limb. So here it is given by pressure below xx in the left limb PA minus of rho into G into H1. So PA is already calculated. So you have to substitute the value of PA. So here you have to substitute the value of PA. Rho 1 is nothing but the density. So here in pipe A, so it contains what? Water. So the density of water is 1000. So here you have to substitute rho 1 as a 1000 and G is nothing but the acceleration due to gravity. That value is 9.81. So here you have to find out the height below datum xx. So this is given 30 centimeter. So first of all, what you can do, you have to convert this into meter. So that it will give 0.3. So you have to substitute 0.3. So the pressure below xx in the left limb equal to this much value you got it. So now what you can do again, pressure below xx in the right limb. So now you have to find out the pressure below xx in the right limb. So this is nothing but PB minus of rho 1 into G into height. So height is how much? Here this height is how much? 0.1. This is total is 10 centimeter. Now convert it to meter. So you will get 0.1. Now rho 2 into G into H2 means what? Oil tube contain water as well as oil. So here oil of specific gravity is 0.8. So now you can, what you can do, convert it to multiply by 0.8 into 1000. So you will get 800 as a density of oil density of oil. So here you have to substitute 800 into G 9.81 into 0.12. So the height of oil below datum is 0.12 meter. So it is 12 centimeter. You have to convert it to meter. So you will get it 0.12. So the value is PB minus of this much. Now what you can do? equating the two pressure we get. If you are equating the two pressure, you will get the value of PB, or the pressure at B, 1.8599 Newton per meter square. So second problem is what? In figure 2.23, here an inverted differential manometer is connected to two pipes A and B, which convey what? Water. The fluid in manometer is oil of specific gravity 0.8. For the manometer reading shown in figure, find the pressure difference between A and B. So here what you can do, you have to find out the difference in pressure A and B. So first of all, specific gravity of oil is given, that is 0.8. So the density is 800 kg per meter cube. Difference of oil in 2 limbs. So first of all, what you can do, you have to find out the difference of oil in 2 limbs. So this is 30 plus of 20 minus of 30, you will get it 20 centimeter is the difference of oil in 2 limbs. So here what you can do, taking datum line at XX. So the pressure in the left limb below XX is nothing but what? PA minus of rho GH. So this is rho 1 into G into H. So here you will get rho value is 1000. G is nothing but the acceleration due to gravity. Below the XX datum, below datum XX, from the center of the pipe, this height is 30 centimeter. So what you can do, you have to convert it to meter. So you will get 0.3. So the pressure in the left limb below XX, you will get PA minus of this much. So pressure in the right limb below XX. Now here in right limb there are two types of liquids. One is oil, another is water. So therefore PB minus rho 1 into G into H1 minus of rho 2 into G into H2. So here H2 is 0.2. Already you have calculated. So this much you will get PB minus 4521.6. After equating the two pressure, you will get PB minus PA equal to 1569.6 Newton per meter square. Now the third problem is, here also you have to find out the differential reading H of an inverted U-tube manometer containing oil of specific gravity 0.7 as the manometer fluid when connected across pipe A and B shown in figure below, conveying liquids of specific gravity 1.2 and 1.0 immiscible with manometer fluid. Pipes A and B are located at the same level, and assume the pressure at A and B to be equal. So what you can do here, figure 2.24 shows the arrangement taking XX as a datum line. So PA is nothing but the pressure at A, PB is nothing but the pressure at B. So the density of liquid in pipe A means what? Specific gravity and multiply by density of water. So you will get this much, and density of liquid in pipe B. So density of liquid in pipe B means water. So density of water is 1000 and the specific gravity of water is 1. So you will get this value. So density of oil, again you have to calculate same as the above. And now pressure below XX in the left limb. So this is nothing but PA minus rho into G into H1 minus of rho 2 into G into H2. So you will get the pressure below XX in the left limb. Similarly, pressure below XX in the right limb. So here equating the two pressure we get, so after equating the two pressure we get this equation after solving, because here what happened in the question only it is given that pressure at A is equal to pressure at B. So this is get cancelled. So next dividing by 1000 into 9.81, you will get the value of H. So you will get the value of H as a 20 centimeter. Now, then the fourth problem is an inverted U-tube manometer is connected to two horizontal pipes A and B through which water is flowing. The vertical distance between the axes of these points is 30 centimeter. When an oil of specific gravity 0.8 is used as a gauge fluid, the vertical height of water column in the two limbs of the inverted manometer when measured from the respective central lines of the pipes are found to be same and equal to 35 centimeter. Determine the difference of pressure between the pipes. So here you have to determine the pressure between the pipes. So solution is what? The specific gravity of measuring liquid is already given, that is 0.8, which is shown in the figure, and the arrangement is shown in figure 2.24a. So let PA is nothing but what? Pressure at A, and PB is nothing but pressure at B. The points C and D lie on the same horizontal line. Hence, the pressure at C and pressure at B should be equal. So, but the pressure at C equal to PA minus rho into G into H. So, you have to substitute the value of rho G into H. So, here rho is 1000 and G is 9.81 and the height H is 35 centimeter, that you have to convert it to meter. So, you will get 0.35 meter. Similarly, pressure at D. Now, what you can do, pressure at C is equal to pressure at B. So here after equating you will get PB minus PA equal to this equation 800 into 9.81 into 0.3. So now you have to calculate PA minus PB equal to 2354.4 Newton per meter square. So thank you so much. We will meet in the next video, properties of fluid mechanics.